Now, a function, for example, alright, sorry guys, a function in everyday language, okay, for example, could be, imagine double a number and add on 5. Double a number, add on 5, okay? So whatever your number is, you got to double it and add on 5. So for example, your input is the x value, okay? So x is regarded as the input. So if I say x equals 1, the output is going to be 2 times 1 plus 5, which is 7. Or you can have f of x or y equals 7. Then you can draw it on the graph as the point 1, 7. Okay? So as you can see, in all of this, in all maths, input is the left, output's the right. Example, x is the left, y is the right. Or, x is the left and f of x is the right. Another way of putting it would be like this. X is 1, and then you could write down f of 1. And what is f of 1 again? What's the output when x equals 1? 7. When you replace any number in, if I say for example f of 2 means when you put in x equals 2. So find the output f of 2. 2 times 2 plus 5? 9. This is the point 2, 9. 2 on the graph, 9 to the right. Now, a function is also called a mapping or simply a map. The set of inputs is called a domain. So for example, f of x equals 2x plus 5, and what I can then say then is that in the domain minus 2 less than or equal to x less than or equal to 2. Do you understand that? That's the domain. The domain is the number of values which you use. So for example, the set of outputs is called the range. So for my question here, okay, the inputs are going to be minus 2, minus 1, 0, 1 and 2. What's the output then? It's going to be 1. It's going up 2 every time. So this one's going to be 3, 5, 7, 9. So does everybody understand that my list of inputs, sorry that's not what I'm looking for. My list of inputs is minus 2, minus 2, minus 1, 0, 1 and 2. And then my list of outputs is going to be I'll put them in blue here. It's going to be 1, 3, 5, 7 and 9, and it gets mapped straight across. Everybody happy with that? Okay.
Where do you want to put that on?
I'm doing, Rory, is I'm doing 2 times 1 plus 5. I'm doing 2 times 0 plus 5. I'm doing 2 times minus 2 plus 5. And 2 times minus 1 plus 5. And that tells you that the answer for the minus 2 is 1. Answer for minus 1 is 3, 0 to 5, 1 to 7, 2 to 9. Now, what happens next is these are the inputs, okay? So, the set of outputs is the range. This is the range here, okay? But what do you notice about both types of numbers? These here are integers, aren't they? Would you agree that they're integers? Minus whole numbers. What about the outputs? The outputs are integers as well, technically speaking. They're a subset of integers. So these outputs are a small portion of a bigger amount of numbers. The bigger amount of numbers is called the codomain. Okay? Codomain. Now, what it says is the range is a subset of the codomain, as in the codomain represents all the numbers from minus a million to plus a million. And all the answers from a range lie in these set of numbers. That's why it's a subset. Does everybody remember what subsets are? Okay, so example would be from sets. If I had all the numbers from 1 to 10, and I said A equals, if U is all the numbers from 1 to 10, and A is the numbers 2, 3, and 4. What I can say next is if I was to draw U, and A would be in the middle. Alright, and then there's numbers outside like 1, 5, 6, 7, 8, 9, and 10. It fits in the middle. It fits into all the numbers in the bigger set. That means it's a subset. Okay? Moving on. Okay, next thing then. Alright guys, what you'll notice is two values, you can have the same value twice. So for example, two of your inputs can give you the same output. Yeah? So that can happen. Okay, so two inputs can give you the same output. Okay? Now, graphing linear, quadratic and cubic functions. An example would be y equals mx plus c from geometry, or rewritten as f of x equals ax plus b. What does A represent? Slope. And C represents the y-intercept, for those of you who don't remember. So example, if you have a line and it hits here, okay, it hits at 4, and I told you the slope is 2. What happens here? The formula is 2x plus 4. If I said the slope was minus 1, and it intercepts at 1 plus 1, the equation would be minus 1x plus 1. Now, the graph is the following. When the slope is positive, it goes diagonal right up. When the slope is negative, it goes straight across. When the slope is 0, it goes straight across. When the slope is negative, it goes diagonal right down. Next thing, if the slope is infinity, do you know what I mean by infinity? Any number divided by 0. What happens? Straight up. Okay? A really, really big number that's not infinity. Look, for example, right? At the moment I'm at a slope of 1. I'm at a slope of 2. I'm at a slope of 3. Now I'm up to about 10. I'm up to about 20, 25. And then all of a sudden the steeper and steeper you go, the closer, the bigger and bigger the number you get is. I'm at about a slope of 200 at the moment. And then back down to 1-ish, back down to about a half, and then back down to flat. Okay, next thing, a quadratic function. Quadratic functions are interpreted by their a, b and c value. Okay? Now, let me give you an example. Example would be this, okay? I'm going to draw an equation y equals x squared minus let's say 10x plus 24. Standard U-shaped curve. Everybody happy with that? It crosses the x-axis at 4 and 6. So the one I just drew there was x squared minus 10x plus 24. Everybody happy with that? A equals 1, B equals minus 10, C equals 24. I want to discuss the role of the last number. See this 24 here? What happens if I change that? What happens if I change that upwards or downwards? What happens? So I'll give you an example. I'm going to turn it into plus 18. What's the gap between 24 and 18? 6. And it's lowered by 6, not higher by 6. Look what happens. Okay, so look. Y equals x squared. What to say was minus 10x, yeah? Plus 18. What happens is, the graph is lowered by 1, 2, 3, 4, 5, 6. Do you understand that? Okay. Let's examine what happens when we change the b value. Okay? Alright guys. So, lads, this time we're going to change the middle value to minus 12x plus 24, okay? So we're going to see what happens when we change the middle value, okay? So look what happens. Y equals... Sorry. Okay. Y equals x squared minus, what did I say it was this time? 12x plus 24. Which one was it?
It's the one in the middle.
The one in there?
It's the big dirty one.
The big one, okay. Alright, so guys, what happens here is we can see that the x value, actually it did two things, didn't it? It sort of, we'll see if it fits into the original one. Oh, it's actually the same size as the original one, believe it or not. But it just got shifted. It got shifted downwards, didn't it? So the extra negative part shifted it downwards and to the right. Do you understand? It was here, the bottom was here, and then it got shifted downwards and one to the right. Is that alright? So let's predict what happens this time. When I increase the negative value, it shifted to the right and down. Let's make it, I don't know, minus 6x. What do you think will happen this way? Up and to the left, maybe, yeah? So let's find out. X squared. X squared. What's it? Minus 6x plus 24 equals 0. And we're going to have to go looking for it. Is it here? There's two of them there, is there?
It's only 3.
Well, I go again. Sorry, I must have entered in. Y equals, what to say, x squared? Minus 6x plus 24.
Sorry, plus 23.
Sorry?
Try plus 23 and see if it shows up then.
Yeah, just give me a second. What you're going to notice here is that this one doesn't cut the axis at all. Do you see that? And it, as predicted, it got shifted up and to the left. Now, the reason why it doesn't cut the axis is if you solve this equation equal to 0, it never equals 0. The y value is never 0 because it never touches the x axis. The reason for this is if you did a minus b formula, you'd get the square root of a negative number, which means it doesn't exist at this point in time. Okay, now the next thing we got to look at is we've learned what happens when you manipulate around the middle number. Now what happens when you manipulate around the first number? For example, if I turn this into a minus x squared, minus x squared will change it to an n-shaped function. Okay? And then you can higher and lower the n-shaped function by changing the last value. Is that okay?
Yeah.
Rewrite a new example, okay, where we could say f of x equals x squared, and then we could try 3x squared. Okay? So let's try this out. New, don't save, okay? So I'm just going to say is y equals x squared. N-shaped graph, y equals 3x squared, yeah? Mm-hmm. Now what I reckon will happen is if you were to put that on your calculator, you'll see a much greater change, a much sharper change. So in effect what it does is it sharpens up the slope and makes it rise faster. So 1 second. There we go. So you can see that it makes it much sharper. So let's predict, what about y equals 6x squared? What do you think?
Even sharper.
Steeper rising again. Okay? So that's what happens. Now, what about y equals x minus x squared? Minus x squared, anybody? N-shaped, okay? N-shaped. Okay, now lads, I'm going to do something here now, okay? That's y equals minus x squared, yeah? Now what happens if I do y equals minus x squared? What about plus 6x? Would you think it'll shift to left or right? Plus 6x shifted it diagonal right up, yeah? Now what about y equals minus x squared minus 6x in the opposite direction? Should shift it diagonal left up and diagonal right up.
So if the function is x squared, it's always going to intercept at 0, 0.
What Simon's just after commented on here is without an end number, it always hits at 0, 0. So let's give an example of one that has an end number now. Y equals minus x squared minus 6x, similar to the one to the left, and then let's put a plus 9 at the end. Now, the plus 9 should raise the old graph up 9. See this graph here? Fully expecting this to jump up 9 when I press the equals, when I press the enter button. Okay, just give me a second. Capital X. There it is there. Jumped up 9 full spots, and when you go down to where it intersects the x-axis, here and here, 2 separate intercepts as predicted. Now guys, next part on to then is going to be our cubic functions, okay? Now, cubic functions follow the following parts, alright? So for example, when a is bigger than 0, a is a positive number, you always have 2 turning points, a max and a min. The maximum, when you're going from left to right, always occurs before the minimum in the case of this graph here. So for example, if I ask you to draw, how would you predict this one will turn out? How would you predict that will turn out? Max first, min second. If I change this to a 20, what does that do? Or 30? Moves it upwards. If I change it to a minus 30, downwards. Perfect. Okay guys, next thing. If a is less than 0, the minimum always comes before the maximum. Are you happy with that? Min before max. I'll give you an example. Min and max, okay? An example of something like this would be minus 3x cubed plus bx squared. Plus, let's call it a 6, looks like a 6. Plus 5x minus 12. What would you think of that? Similar shape to this one. Here, change the d value at the end, brings it up or down. Perfect. Alright guys, moving on. Now, a lot of this is do here is the following. I'm going to show you some tricks here, okay? Find the values for which f of x equals 0. Okay? Well, what we can say here is that, hey looking, it's when f of x represents the y value of the curve. You got to find the y value of the curve when it hits 0. When it hits 0, it means it's on the x-axis. So if you here, which is minus 1, x equals 1, and x equals 3. Is that alright? Now, there's something that you need to know about this, okay? If I wanted to make this an equation, it's a cubic equation. Would everybody agree it's a cubic equation?
Yeah.
Would everybody also agree that it's a positive cubic equation, as in if I was to say ax cubed plus bx squared plus cx plus d, everybody would agree that a is a positive number.
Yeah.
Now look at this guys, right? I'm going to show you something here. Right? X equals minus 1 is one answer, x equals 1 is the other answer, and x equals 3 is the third answer. Now look what happens when I bring them over one side. Okay, what I can get here is going to get x plus 1, x minus 1, x minus 3. Yeah? And that equals 0. Do you know the same way you solve a quadratic, you can solve a cubic in a similar fashion. Either the first number equals 0, the second number equals 0, or the third number equals 0. Now look at one other step. Right? I'm going to multiply these out. And I'm going to get x squared minus 1 bracket x minus 3. Now, look what happens here. Okay, so we're going to get x cubed minus 3x squared minus 1x plus 3 equals 0. Now I want you to, this could be the function. Do you understand what I'm saying? This could be the function. So if I was to map this function out, will somebody take this number down and remember it for me? Okay guys, so look at this, alright? Now, if you were to draw this using your calculator, right, you can take any range, you can take any domain you want. So what did we say the formula was again? Y equals?
X cubed minus 3x squared minus x plus 3.
Minus x plus 3. Now look, it's exactly the same diagram as we had in the last part, correct? Now, there is one stipulation though. Here's your stipulation here, okay? What happens if I multiply all of this by a number, any number of my choosing, let's say from 1 to 5. So, example would be, I'm going to change into 5x cubed minus 15x squared. Take this number down for me. Minus 5x plus 15. Okay? Now look what happens when I multiply the full equation by 5. Okay? Anybody got it?
5x cubed.
Yeah, so cheers. 5x cubed, yeah.
Minus 15x squared.
Minus 15x squared, yeah.
Minus 5x plus 15.
Minus 5x plus 15. Now look at this. What have I done?
Increases.
I've increased the steepness of the I've increased its steepness by 5. But what you know is about the x values? The x values stay the same. So what happens is, when you want to find out the original equation, I know it wasn't part of the question, but if you wanted to find out the original equation from this, you'd also need to know one other point to figure out how high it actually goes upwards. Would that make sense? Okay. So you need to know one other point to figure out how high I should go. Because it could be any number multiplied by this would give you the same shape. But you'd need to know how steep you're going. Does that make sense? Okay. Moving on. Example 2. Find the values for which f of x equals 6. This question is asking, find the value of the curve when y equals 6. So look, you go to your line y equals 6, it's up here, and you draw a line going across, and you intercept the curve at minus 1.2, 1.3, and 3.7. Okay? And that's all there is to it. Okay? Now, it can be asked another way. I'll give you an example of I'm going to go back to my equation back here. Okay? I could ask this in another way. Okay? Let's say this is my original equation. Okay? What I could ask is, now my original equation is drawn, just give me a second. Okay. Now, everybody's happy that this is my original equation. This is the equation of, everybody's happy that this is the equation of x squared minus 3x squared minus 1x plus 3. Everybody's happy with that?
Yeah.
Now, I could ask this in two ways. I could ask this value here. I could do it like this. Find the value for which this equals, let's say, the number 4. Does everybody understand that this whole equation represents the y value? It's basically me asking y equals 4. You happy with that? And what the answer would be, when y equals 4, there's only one answer, isn't there? Here, and drop it down. Yeah? About 3 point something. Now there's another way I can ask this. I could bring the 4 over the other side, and I could manipulate the question into using your graph. I could say, using your graph, solve. And what I'm basically doing is I'm asking you the same question, but I have it in disguise because I moved the 4 over the other side, changed it to minus 4. And all of a sudden, you're left with this equation. Use your graph to solve this. And the first thing that everybody will tell me is, look, it's not the same graph. Because this one, it's the same for the first 3, but it's not the same for the last one. So what you will always do is you will make it the same as the last one. So what you'll do is you'll change the minus 1 into plus 3 minus 4. You'll split it up. You'll send the 4 back where it came from over the other side. And then you'll get your original question back. So that's the way they can fool you. They can ask you the same question about 3 different ways. Okay? So moving on. Okay. Local maximum, local minimum. Okay? Now, often we're asked to find the local maximum and minimum points, or the local maximum and minimum values. Consider the graph on the right. The local maximum and minimum points are where the graph turns. For example, 1, 4 is a local max. 4 minus 2 is the local min. Okay? The local now, that's the maximum turning point. So the max turning point, if you're asked for the point, you write down the full point. If you're just asked for the minimum value, do you understand? If you're asked for the maximum or minimum value, you only ever take the y value into consideration. So for example, the max value would be 4 and the min value is minus 2. Maximum and minimum value is also referred to as local max and local min. Is that alright? Okay, moving on. Increasing and decreasing. Graphs are read from left, which is your start, to your right, which is your end. Okay? Increasing. If the function is increasing, the graph is rising from left to right. So is it increasing at the moment? Increasing, turning point, decreasing, turning point, increasing. Is everybody happy with that? Now, Find the values for x for which f of x is increasing. It's increasing. Are you looking? It's increasing at, let me see. Increasing, sorry. Now, it's increasing for any values smaller than minus 2, because it's just going to keep going down this way indefinitely. So I'd write down this answer here. I'd write down x less than minus 2. It's always increasing. Do you understand? It's always on its way up. There's no other turning points left. Now, why don't we include 2? Why is it not less than or equal to 2? Because when it reaches the top, it's no longer increasing, it's flat. It doesn't go up any further. So that's why we don't include the top. When is it also increasing? Any value bigger than 1. X greater than 1. So are we happy with that? Now, you notice in the book, they put in a stop at minus 4 and 3. You'd only do that if you're asked. Okay, usually you just give the general value. Alright guys, what about decreasing? Anybody tell me anything about decreasing? Decreasing? Falling from left to right. Yep.
X greater than 1.
Starts at minus 2, ends at 1. So minus 2 is less than x is less than 1. And any other time it's increasing. At x equals minus 2, at the turning points, the graph is neither increasing nor decreasing. Okay. Now, so 2 functions are graphed on the same axis, okay? The diagram shows the graphs of 2 functions, a curve and a line. Find the values for which f of x equals g of x. What does f of x technically mean, guys?
Y.
It means the output of the curve, or the y value of the curve. What does g of x mean? Output of the line, or the y value of the line. This question technically reads y value of curve equals y value of line. Where are the points the same? They're the same here, here, and here. Do you see the way the equation is written in terms of x's? See the way it's x and x. Do you understand that? X and x. That means the answer is also going to be in terms of x's. Do you got that? Now, next one. F of x, the values for which the curve is smaller than the line. Alright? It's smaller than the line here at the moment, and then it stops being smaller than the line. So it's any number smaller than or equal to 0.4. You understand that? It keeps going downwards forever now. So any point below minus 0.4 is smaller than the line. Next thing, line is bigger, line is bigger. Curve is bigger, curve is bigger. Now the curve is smaller again. Where is it smaller? In between 1.4 and 3.1. Is that alright?
Presume it doesn't curve back up again.
No, because it only has 2 turning points because it's a cubic graph. So it can't turn again. It can't turn back down.
X to the power 4.
You can, but it won't be a cubic equation then. It's specified that's x to the power 4. Okay. Next thing, guys. F of x is greater than g of x, okay? F of x is greater than g of x. What happens now, guys? F of x is greater than g of x.
Above the line.
Above the line. So it starts here and ends here. 0.4 less than or equal to x less than or equal to 1.4. Then it starts here again and goes upwards, which would be x greater than or equal to 3.1. Okay, we're nearly there.
Will these be like small little theory questions we'll be asked?
Now, graph above and below a constant value and inequality. Find the values for which f of x is greater than 2. Find a value for which the y value of the curve is bigger than or equal to 2. You go to y equals 2 and you draw a line going directly across. Then you draw the point at which it hits downwards, and then you put this range in. It's going to be point A less than or equal to x less than or equal to 0.4. It also gets bigger than 2 at x equals 3.3. and any value bigger than 3.3, it's bigger than y equals 2 line. So the other answer would be x greater than or equal to 3.3. If you're only talking about your function here, you can also stop it at 4, and that might explain your less than or equal to 4 part. Any questions on part 1? Part 2, on or below the line y equals 2. On or below would incorporate this part here, this part here. So what we're going to get, I'll just shade it in blue actually, what we're going to get is any number smaller than minus 0.8, or any number in between 0.4 and 3.3. Everybody happy with that? Moving on. Number 9. Using two graphs to estimate the square roots of cube roots. Okay. Alright guys. This one here. Use two graphs to estimate square roots and cube roots. Okay. The diagram shows a cubic function. And as Simon would say there, it's a positive a value. As in it's a positive cubic. It's not minus x cubed. It's plus x cubed. Means the maximum comes before the minimum. The other one is a line 6 minus 3x, which cuts down here in the domain minus 2 less than or equal to x less than or equal to 3. Show how the graphs might be used to estimate the value of the square root of 2. Now, what we can see is that the graphs intersect at x equals 1.3. Are you happy with that? X equals 1.3. Now, what this means is that the y value of the curve equals the y value of the line, which means that x cubed minus 3x plus 4 must equal 6 minus 3x. Now look what happens here. When you solve it algebraically, okay? Now what we're looking for? When you solve it algebraically, what you're going to see is you're going to get x cubed equals 2. Okay? And bring this over to the other side, x equals the cube root of 2. The answer to this question is the cube root of 2. Therefore, the answer to it graphically is also the cube root of 2. So you can get, hence when the two graphs meet, it can be used to estimate the value of the cube root of 2. Where the two graphs intersect, draw a broken line down to meet the x-axis. The x-axis meets at 1.3. Using the graphs, we estimate the value of the cube root of 2 to be 1.3. Get the cube root of 2 on your calculator. There is there. You should see it's around 1.3, 1.26. It's very close to 1.3. That question, very popular in this exercise. So what you'll always do is you'll solve it geographically, then you'll solve it algebraically, and whatever answer you get in your graph should be equal to whatever answer you get in the algebra question.
Where did you get 6 minus 3x?
Here. It's the y value of the line equals the y value of the curve when they intersect each other. Okay. Matthew. Okay. Number of times a graph meets the x-axis. The number of times a graph meets the x-axis gives the number of roots of its equation. Often we need to find the range of values of a constant which shifts the graph up and down. We talked about shifting the graph up and down earlier, didn't we? Okay. Given the graph a certain number of roots. For example, for what value of k does the equation f of k have 3 roots? Alright guys, look at this. Example would be my equation I did earlier in part example 1. What I could technically do here is I can technically raise it up and raise it down according to how many roots. At the moment it has 1 root. When I raise the d value, now it has 3 roots. Here it has 2 roots. The d value controls the height, therefore it also controls the number of roots. So what we're going to see in the next question here, okay, here's an equation. At the moment it has 1, 2, 3 roots. You happy with that? 3 roots, okay? Now, it stops having 3 roots at y equals 2 and y equals minus 1. Okay? Now, the equation f of x equals k will have 3 roots if the line y equals k cuts the graph 3 times. Any line that I throw through it that hits 3 times will have 3 answers. Okay? Now, so we have to draw lines parallel to the x-axis that cut the graph 3 times. The range of values of k will be in between the lowest and highest value on the y-axis. So the line y equals k plus 3 times. The range of the values of k is found by finding the range of the equations of the lines. Any lines drawn parallel to the y-axis between y equals -1 and y equals 2 will cut the graph 3 times. Therefore, the answer for k will lie between -1 and 2. K represents a line, a horizontal line. For example, guys, if I drew a line here, what would this be? What equation would this be, technically? If I drew this line here. That is f of x equals 3. Okay? Because the y value is always 3. If I wrote down f of x equals -2, where would that be located? Down here. F of x equal to any number in between -1 and 2 will hit it 3 times. So this function, or this horizontal line that it represents, has to be in between -1, k and 2. Alright guys. This one here, okay? Number 11. Graph the function f of x equals 2 minus 9x plus 6x squared minus x cubed in the domain -1 less than or equal to x less than or equal to 5. So look at this, guys. You go to your Casio, you've done this already. Okay, now you get marks. We did our own type of table the other day, and you get marks for the table. So we're going to get is minus x cubed plus 6x squared minus 9x plus 2. Okay, guys? Starts at -1, ends at 5. Now, step 1, you get all your points here to draw. Do you understand? You're going to draw all these points. Once you've drawn all these points, you then get the following graph. And now you're asked to do some questions on this graph. Okay? So, example would be, estimate the values of x for which f of x equals 0. What does f of x equals 0 mean again? Y equals 0. Where does the curve meet the x-axis? Where does it meet the x-axis? Point 3, 2, and 3.7. Done. Estimate. This question could also be asked like this. Do you see it there? Find the values of x for which 2 minus 9x plus 6x squared minus x cubed equals 0. Everybody happy with that? Now, what about this question here, guys? Look up. What about this question here? What am I basically asking here? Find the values for which 2 minus 9x plus 6x squared minus x cubed equals 2. What have I? It's basically y equals 2. Well done, whoever said that. And the answers are going to be 0 and 3. 0 and 3. Okay? Now, what we're going to do next is this. Estimate the value for which the x value is minus 0.5, but what is the y value? Go to x equals 0.5 minus 0.5. Where is it located? It's located here. And then work your way up, and it hits it around 8. 7.98. So we can see that at 7.9. You can also check your answer. How would you check your answer algebraically? You can replace all x's with minus 0.5. Sorry, that's 0 now, yeah? Minus 0.5 cubed, and you should get an answer close to 7.9. Estimate the value of x for which f of x is bigger than 0 and is increasing. Now, let's mark out the places where it's increasing. It's increasing here. It's only increasing in between here and here, isn't it? Now, how do I eliminate out it? Also has to be
greater than
x also has to be greater, the y value has to be greater than or equal to 0. So technically only starts around 2, but doesn't include 2. Minus 2 less than or equal to x. Does it include 3? Is it less than or equal to 3 or less than 3? It's less than 3 because the question specifically states increasing. That's why it's not included. Is that alright?
Yeah.
Now, estimate the real values for k, where f of x equals k is a horizontal line for which it has more than one solution. More than one solution. Okay? Well, it has two solutions. It technically has two solutions here, doesn't it? You go to the point at which it cuts the graph twice. See y equals 2 and y equals minus 2? That's the point at which it cuts twice only. Anything above this line it cuts once, and anything below this line only cuts once. So the answer is going to be in between minus 2 less than or equal to k less than or equal to 2. Because any line in between here cuts 3 times. Now, example 12. Okay, now this one is tricky. Watch out for this one. Okay guys, what you're going to get is the following, alright? You're going to be given a function f of x equals x squared minus 6x plus 2. You're going to be asked to express it in the form of this, okay? Now, to express in this form, what I'll always do is I'll always look at the middle value. I'm always looking at the value that comes in front of the x. If it's a negative value, okay, it's always going to be a negative value in the bracket. So, what's asked me to do is I do it this way, okay? I half this value here. I get x minus 3 squared. X minus 3 squared is x squared minus 6x plus 4. Plus 9. Now, what's the difference between this function and the function here? There's 7 extra, isn't there? Because it should be 2, but it's 9 franc. Okay? So, what we get here is we got to take away 7. Then we can rewrite this part as what it was. X minus 3 squared minus 7. Done like there. Hence find the minimum point f of x. Now, the minimum value is the value at which it's at its lowest. We've identified this as a U-shaped curve. Do you understand? It's U-shaped because it has a positive x squared value. That means it hasn't got a maximum, it'll only have a minimum. Now, once you've verified this, now look what happens to it. X minus 3 squared is an interesting number. If x equals 0, what's the answer to it? Minus 3 squared, which is 9. If, let's say, for example, if 3 is the answer, what is it now? It's going to be 3 minus 3, which is 0 squared. And 0 squared gives the smallest number of 0. What happens if we were to use, I don't know, minus 6? What happened if we used minus 6? We'd get minus 9 squared, which is 81. So what you're telling me is, to get the minimum point, what you got to do is you got to always set this bracket to 0. How'd you set that to 0? X minus 3 equals 0, and therefore x equals 3. The minimum value, if you were to draw this out, occurs at x equals 3. You know x equals 3, but then again, what's the y value if that happens? What's the y value if x equals 3? Okay, so when x equals 3, we know that f of x equals x minus 3 squared minus 7. Therefore, f of 3, as it's written down, if the input is 3, the output is... Oh, sorry, I made it. Yeah. If the input is 3, the output is going to be minus 7. This is the point 3 minus 7, which is the minimum point. Please be aware that an axis of symmetry also crosses up through the middle. Is that alright? Now, okay, next question. Sketch f of x and state its range. F of x, you'd obviously draw it from you could get some points on it quite easily. Okay, so the points you could get are like this. There's an easy point to get. You know that 3 minus 7 is a point. But another really easy point to get is put x equals 0. And if x equals 0, what's f of x? 0 minus 0 plus 2. 0, 2 is another point. So all we have to do is sketch it, go all the way down to 3, 7, and go the same amount up the other side. Okay? So, if you see the way it's a gap of 3 from here to here, then it's going to be another gap of 3. So this point here will have to be 3, 2. And that's how you can draw your sketch.
16.
Huh?
16.
Oh, sorry, 6, 2. 6, 2, sorry. Because 3 plus 3 is 6. Sorry. Alright, guys. Shh. Now, we gotta state its range. What is its range? A range is all its possible values. What value can y not go underneath? Minus 7. Therefore, the range has to be bigger than minus 7. Alright, guys. That's the last one here. 26, okay? The graph of the function f of x equals ax cubed plus bx squared plus cx plus z, where x is an element r. This means x represents any number, positive or negative, decimal or fraction, doesn't matter. Write down the value of d. Now, the trick is with d is the easiest piece of information here is 0, 6. Why is that the easiest piece of information? Because the input is 0 and the output is 6. 6 is this part here. 6 therefore equals a times 0 cubed plus b times 0 squared plus c times 0 plus d. Therefore 6 equals d. You now know that's 6. Now, I want you to find the values of a, b and c. To find the values of a, b and c, you need to find points that have no value other than real numbers. This is an example of one of them. This is an example of one of them. And this is an example of one of them. Well, I already used 0, 6 to get the first. You're right. 0, 6 is an example, but I've already used it to get information. Okay? So, look what happens here, okay? F of x equals ax cubed plus bx squared plus cx plus 6. Now look what happens here, guys. Okay, let's start off. Input is minus 1. Output is 8. 8 therefore equals a times minus 1 cubed plus b times minus 1 squared plus c times minus 1 plus d. Now look what happens here. Bring the 6 over the other side. 8 minus 6. 2 therefore equals minus a plus b. Minus 1 squared is 1 plus b minus c. That is equation 1.
Plus 6, no.
The 6 is brought over the other side. That's equation 1. Equation 2 is 2 minus 4. Input is 2. Output is minus 4. Now look at this. Minus 4 equals, minus 4 being the output. Okay? Minus 4 equals a times 2 cubed plus b times 2 squared plus c times 2 plus 6. What we're now going to get is we're going to get minus 4 equals 8a plus 4b plus 2c. The 6 goes over the other side, becomes a minus 6, and now we're going to have minus 10. That is equation number 2.
Can you divide that through? Or
I can divide that by 2. And what I'll get is minus 5 equals 4a plus 2b plus c. Okay. Now, that's b, that's a. Now I'm on my last point. Which is the only point I haven't used yet?
It's 418.
418, okay? So 418. Now I have to go into 418, okay? It's going to be 18 equals a times 4 cubed plus b times 4 squared plus c times 4 plus 6. Put it all in. 18 equals 64a plus 16b plus 4c plus 6. Oh, sorry, bring the 6 on the other side. And it becomes a 12. Divide by the number 4. 3 equals 16a plus 4b plus c. Upon completion of this, what you're next going to do a simultaneous equation, and unfortunately 3 variables. Okay, so look at this. There's the first one, there's the second one, and the third one is located up here. Now, what you've got to do is you systematically got to cut out one of the letters and make 2 equations that will make a normal simultaneous equation and work your way backwards. So an example would be this. Okay, I'm going to cut out C right from the start. Okay, and to cut out C, what I'm going to do is, sorry guys, to cut out C, what we're going to do is this. I'm going to do A plus B. Now write down what you're using, A plus B, okay? So A is going to be minus A plus B minus C equals 2. B is minus 5 is 4A plus 2B plus C. What we're next going to get is we're going to get 3A plus 3B equals minus 3. Divide by 3. A plus B equals minus 1. Once you're done with that, you can just move that off to the side, store it, this here, and just make sure you colour it in. That's what you need. That's equation D. Now, I've used A and B. What would be another good combination?
A and C.
A and C would be a nice combination. So it's going to be 16A plus 4B plus C equals 3. Minus A plus B minus C equals 2. We're going to get 15A plus 5B equals 5. Nice numbers. Divide by 5. 3A plus B equals 1. That is equation E. Now and only now can you put them back in. So I'm going to do E minus D. So I'm going to do 3A plus B equals 1. Minus A minus B equals minus 1, which is 1. 2A equals 2. A therefore is 1. If A is 1, 3A therefore is 3. 3 plus B equals 1. B therefore is minus 2. A is 1, B is minus 2. Go back to the start. A is 1, B is minus 2. 2 equals minus 3 minus C. And what can you do with the minus 3? Move it over to the other side. Minus C equals 5.
C equals
C equals minus?
C equals 5. You brought over minus C.
It's minus 1 minus 2 equals minus C. I brought over the minus... Sorry. I technically brought over the minus 3 and skipped a step. So look, I did actually... This is what I did. I brought over the minus 3. So it's 5 equals minus C. Then I spun it around.
Alright.
And then C equals minus 5. Alright? Alright guys, so A is 1, B is 2, and C is minus 5. So that's 1. What did we say B was again? So it's 1x cubed minus 2x squared. C is minus 5x plus 6. Okay? Now, you could verify your answer. How would you verify your answer in a test? I could just do this right now. Okay, I could just say, okay, I am sure if this is right or wrong. So what I'm going to do is I'm going to enter in this equation into my calculator here. Now, if everything's right, I should get all the points that are already there. So look, this is a really, really easy way of doing this. Okay, this saves a lot of time. X3 minus 2x squared minus 5x and then plus 6. Now, what's the range? I want it minus 1, minus 2. Let's go for minus 4. Hopefully we get everything we need. And what's the end?
18.
4. It's the x value, not the y value. Now look at this, guys. See if it works out. Minus 2, 0. We already know what p is, don't we? What about minus 1, 8? Check. 0, 6. Check. 1, 0. Check. 2 minus 4. So look, we've already figured out what p, q and r are. And if you're in a hurry, guys, it's the best way to do it. Now, let me show you the official way of doing this. Yes? This brings us back. This whole thing now is like a complete revision of chapter 1 algebra. It brings us all the way back to the factor theorem. We got to find out, where does the y value equal 0? If this is our function, guys, excuse me, if this is our function, okay, if this is our function, then where does this value equal 0? Now there's a way of doing this, guys. The way of doing it, first and foremost, is I would have checked my function and found out which one works, okay? So what you actually have to do is you actually have to factorize 6, and then you take factors of 6, like for example 6, you can take 6, 3, 2 and 1. You can check the minus or the positive values of each one, okay? And what you know what I mean by checking is that you put it in, and if it equals 0, it's one of the answers. So here's the way you technically have to do it. We already know that one of the answers, I'm just going to do it, but try. One of the answers is minus 2, so look, I'll just replace it with minus 2. Minus 2 cubed, minus 2 times minus 2 squared, minus 5 times minus 2 plus 6 equals 0. You're going to get minus 8 plus 8. Is that, no, sorry, what was it? Is that plus 8?
Minus 8.
Sorry?
Minus 8.
It has to be minus 8, yeah, sorry, because the extra minus on the outside. Minus 8 plus 10 plus 6. Minus 16 plus 16 equals 0. You now know that that's, if x equals minus 2 is a root, x plus 2 is a factor. You then go about dividing x plus 2 into x cubed minus 2x. Now, to be honest, guys, you can do the long division way. You can get a quadratic equation and solve it. You guys have the power of a calculator. So what you guys can just do now is this. You can just choose your other two values to put in. You know, one answer is minus 2. You know the other answer is? Where is it? 1. And you know the last answer is 3. So you can just do f of 1 and f of 3. You don't have to go through the long division. In tomorrow's class, I'll show